Hello friends, welcome to the basics of digital signal processing. In this session, we will go through the classification of signals. Let us have the listing of the classification of signals. First one, multi-channel versus the multi-dimensional signal. Second one, continuous time versus discrete time signal. Third one, continuous valued versus discrete valued signal. The fourth one, deterministic versus the random variables. Let us start with the multi-channel versus the multi-dimensional signal. So, first with the multi-channel. So, if you are going to get a signal from several sources, we call that as the multi-channel signal. For example, earthquake data, that's the seismic data, what we are going to call. So, that will not be taken from one location, that will be taken from multiple locations for processing. Similarly, ECG data will be taken from different locations of the body. Like that, EEG data, that is the content of the signals from the head that is being processed. It is not taken from a single source, that will be taken from multiple locations of the head or the multiple channels, what we are going to call. So they are all come under the category of the multi-channel signal. We will go through the example with respect to the waves later. Then coming to the multi-dimensional signal. So there is a possibility that the dimensionality can be single or multiple. In order to differentiate, we are going to say that if it is with respect to a single variable representation, a signal or whatever it is, we call that as a single dimensional. If it is from two variables, we call that two dimensional. So like that, so multi-dimensional means m number of variables we are going to have. So that m dimensional we are going to have, we call that as the multi-dimension. Right? So example, so signal is one dimension, an image with a grayscale, two dimension, color image is a three dimension. Now let us go through the example for both multi-channel as well as the multi-dimensional. So first one going with the multi-channel realization. So this for the seismic data, that's the earthquake related data. So here the data is being taken from three different channels that is being processed later. So like that, with respect to ECG, as you can observe over here, so it is not from a single channel, again multiple channel. Also EEG, it is also from multiple channels that has been taken. Right? So this is called multi-channel. Now getting into the multi-dimensional. So as you can observe, so this is just a simple sine wave, or you can also consider a cos wave. So it varies with respect to the time, single variable. So we call that one dimensional signal, right? So this is a two dimensional signal, that is a grayscale image. It varies with respect to two variables. We can just call that as x comma y, two variables, right? So that's why it's a two dimensional signals. And if we consider a color image something like this, then it consists of three layers of representation, or it's a function of three variables x, y and z we can consider. So that's why this is going to be a three-dimensional data, right? Like that, if we are going to have some other kind m-dimensional data, so in general we call that as now the multi-dimensional, 1D, one dimension, two dimension, three dimension, four dimension, etc., etc. In general we call that as the multi-dimensional information or the data. Now getting into the next one, continuous versus the discrete time signal. Now a signal is said to be continuous signal if t is a continuous variable. For example, sine wave or a cosine wave. So here a sine wave is being represented. In other term, we can also say that x-axis is the time, that's what the variable we are going to consider. At any instant of time, we can have a amplitude value of the signal at any instant of time. Just like the value is 1, at 1 we can have an amplitude, at 1.001 still we can have an amplitude value. That's why we call this as a continuous signal. At all instant of time we can have the amplitude of the signal. Now getting into the discrete signal. So a discrete signal is represented by x of n, where n is a discrete variable. So it can be obtained by sampling the continuous signal. So this is also a function with respect to single variable only, but not with respect to the time. We call that with respect to a discrete variable n. For example, here we are going to consider x of n is equal to 0.8 to the power of n if n is greater than or equal to 0, 0 otherwise. So for this function, the discrete signal graph has been drawn over here. So n is what? The single variable function we are going to have, single variable we are going to have, and here is the amplitude of the signal, right? So amplitude is defined only at certain locations, that is 0, 1, 2, 3, etc. that has been taken. If it is asked what is its value at the location 1.1 or 1.5, no, we don't have any values for that. It is obviously we are going to say it may be 0, but we are not, there is no values to be defined. So this is called discrete. That means only at n is equal to 0, 1, 2, 3, dash 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 equidistance locations we are going to have values for them. In all other locations we don't have values for them. That's what we call this as discrete. Similarly, here we are going to have a sine wave realization x is equal to sine of 2 pi n. So this percentage pi, this is with respect to Scilab that has been drawn. So that's why same function is being represented over here. This is what the result we are going to get. One complete wave has been drawn, and as we can observe, this is discrete in nature. So between two lines, there is an equidistance from starting point till the ending point. Between two amplitude values, there is an equidistance representation, and this is also with respect to the single variable, that is n. Now continuous valued versus discrete valued functions. So what we had gone through previously, continuous versus the discrete signal. So there is no much difference between that as well as this realization. But anyhow, let us go through this also. Now, if a signal takes all possible values on a finite or infinite range, it is said to be continuous valued signal. So that's what I told before. At any instant of time, we can have a definition or we can have an amplitude of the signal. So that can be a finite length or infinite length. Now, if a signal takes finite set of possible values, it is said to be a discrete valued signal. So these values are equidistance. I told this before. A discrete time signal having a set of discrete values is called the discrete signal, right? So this is already shown in the previous example. Now getting into the last one, the deterministic versus the random signal. So as the name itself indicates, deterministic in the sense it is identifiable. That means the behavior of the signal is known for us and it can be represented through the formula that is called a deterministic signal. It can be a linear equation just like S1 is equal to 5t what we had seen previously. So that is a deterministic. Keep substituting t is equal to 0, 1, 2, 3 or any other values. So we will have a value, we will have the result that will never change for that particular value. If t is equal to 0 means the result is 0. That 0 answer will never change unless we change the input value t is equal to some other value, right? So that means the representation is deterministic and it's a constant realization, and we can show that through a formula. We call that as the deterministic signal. Example, a linear equation with fixed number of variables, right? So all the S1, S2, S3 what we seen at the beginning of this session. So the same, all those three are applicable as a part and parcel of the deterministic signal. Now getting into the random. So these signals will evolve over a period of time. They are not predictable. They are not predictable. It cannot be described accurately by any explicit mathematical formulas, right? So that means random means it is not predictable. For example, traffic on highways cannot be predicted by a formula because it depends on the behavior of the human either to go in that road or not. So once he may decide to go with the two-wheeler or once he may go buy a car. If it is buy a car, all 5 persons in one car. Same persons, if they prefer to go in a bike, then 5 vehicles will be there. So traffic has got changed from one car to one car vehicle to 5 bike vehicles. So traffic has got changed. So it cannot be determined in a straightforward manner. Therefore, we call that as a random signal. Thanks for watching.